Maybe you wanted to start assessing your guitar pickups like I do, but you didn't want to spend any money on equipment. Well, I have some good news. As long as you get this program, which is Waveforms, it's free to download, have a audio interface of some kind, it doesn't need to be a Focusrite, then you can actually do the exact same thing I do by plotting out my guitar pickups frequency response. The only missing piece that you're going to need is an exciter coil. So what an exciter coil is a coil of wire that's kind of like a pickup, only it's only wound about 200 times around anything. It doesn't need to be a pickup bobbin, it doesn't need to be this, it could be anything. It could be a popsicle stick, whatever. What it ends up doing is it transmits a frequency from waveforms into the audio interface, out through the headphone jack, which I have clipped in to this circuit that I made. It goes all the way to the exciter coil. The exciter coil vibrates at that frequency that Waveforms is giving it, and then it goes through the pickup and all the circuitry inside the guitar, comes out back into the audio interface, and then is picked up by the Waveform software, which will tell me exactly where this pickup is most efficient at picking up different frequencies. In this case, this is 4.5 kilohertz. Now I know that for a guitar pickup in my guitar with the kind of circuits that I have, getting assessed this way, that 4.5 kilohertz is going to be about the same as a Fender 5762. It's going to sound a lot like those early 60s, late 50s pickups that Fender was known for before CBS acquired them. But with my pickups here, they're kind of neat because you can pick between that coil winding and then other coil windings that make it a lot hotter, something like you'd hear on a Texas Special blues pickup. So what's going to happen to this resonant peak when I go ahead and change the pickups from their vintage setting into their overwound setting? Let's take a look. As we can see right off the bat, we have a little bit more output, which makes sense. The more coil windings we have, the more output the pickup gives us. Now we're seeing something interesting happen. So that resonant peak frequency is actually lower, around maybe just over 3.25 than it was with the vintage pickup. So what does that mean? What that means is the pickup in the overwound mode is more efficient at picking up lower frequencies than it is in the vintage mode. And this makes sense. If we have a guitar pickup that we wind hotter and hotter and hotter, we get more of those blues, Texas Special kind of pickups that are way more efficient at picking up the mid-range of the sound. This is why when you wind a pickup more and more, or you see that a pickup has a higher resistance value, that it has more of a mid-range sound. Because as you add coil windings to a pickup, it becomes more efficient at picking up frequencies that are slightly lower than the treble end and becomes better at getting those mid-range frequencies. So what this allows me to do is if I have a pickup that I like the sound of and I want to emulate it, then I just have to make it match the curve that is there. Or if I have a pickup that I don't like the sound of and I want to change it, then I can know exactly what direction I want to change it on the plot or by how much I want to change it. Now this starts getting really interesting when we start assessing pickups that are not in our guitars anymore. So if I just wound this pickup, not that long ago, and I want to see what it's going to sound like, or I want to make sure that it's like the other pickups in the series of these double tap pickups that I have, then I can use this exciter coil in order to assess that. There's also a large community of people online who have done this for tons of pickups, and there's a bunch of graphs and charts that you can look up to know exactly what kind of a resonant peak frequency and characterization a pickup has in a certain setup. Now, in that certain setup, what most people do is they put a 470 picofarad capacitor, or that orange thing, plus a 200 kilo ohm resistor in parallel with the pickup that they're assessing. And that is what this circuit does right here. So I can actually take this switch and I'm going to flip it on, and that's going to put the capacitor and resistor in parallel with the pickup that I'm going to clip into these leads. Now what we have is the Focusrite sending that signal all the way through to the exciter coil feeding that signal into the pickup feeding that signal into the circuit board. The circuit board is now in parallel with the resistor and capacitor because the switch is on, and it's feeding into the cable that's plugged into the input of the Focusrite and then into the Waveform software. So let's look. So now we can see that we have this plot here, and it's a lot different than the one from the guitar. And the reason for that is you can't like compare the fake circuit to the real guitar circuit. It's just not really a fair one-to-one comparison. But what you can do is you can take this fake guitar circuit and this plot value and then go online and look at some of the graphs that people have to determine what your guitar pickup is going to sound like. Here's an example of what that table looks like. So this is the Echoes of Mars forum, where they have all these different pickups from all these different manufacturers and all the data that we just gathered on them. So if you want to make a guitar pickup that sounds like a Lawler Vintage Blonde, then we know that we want to target a resonant peak frequency that I believe is 4.8. Yep, so loaded resonant peak, that's what we were testing for with the fake guitar circuit. And the Lawler Vintage Blonde has a resonant peak frequency of 4.8. So if we can emulate a pickup or make a pickup that has a resonant peak frequency of 4.8, it's going to sound similar to the Lawler. You found this interesting, and if you don't want to go through making one of these circuits and exciter coils, I do have them available on my shop, so check that out.